All right, excellent. All right, thank you. Yeah, thank you again. I echo everything Maggie said. I'm Andy Lyons. I'm with the Informatics and GIS program. I'm a program coordinator. So myself and Sean Hogan, who you'll be seeing a lot of over the next few days, we're going to introduce a little bit more of the program of DroneCamp and talk a little bit about the drone mapping workflow. All right. So a couple logistics on Zoom. So people are already figuring it out and see the chat window there. So for this DroneCamp, we're using both webinar sessions and meeting sessions. This is a webinar session, so there's fewer buttons that you have on your toolbar. General note, if you have a question that you'd like the presenter to address, put it in the Q&A window. And everything else, you can use the chat window as people are using here. Maggie mentioned all the sessions are being recorded. Take note that recordings do capture the chat window contents, so be aware of that. We will try to get these recordings to you as quickly as possible. We're still trying to figure out how that will work, but I think we'll be able to do it the same day because I know some people are working and many people have asked for these recordings. Okay. We are, like everybody else, we're learning a lot about online programming and Zoom. I think I've learned more about the dials and levers that Zoom has in the last couple of months than I really wanted to know. We do expect some bumps, so bear with us. We're trying to figure it out and we're all getting better, but I do feel like this is kind of early technology and we are pushing Zoom in ways that it wasn't designed to provide. Please be patient. That the website, the program is your go-to place for all the information on sessions. It is being updated maybe once a day or so, so click refresh on your browser to make sure you're getting the latest version. If you have not already, check the emails that we send out. Make sure you've signed up for the concurrent sessions, which start tomorrow. The links to those concurrent sessions are being emailed to you. Some people have told us those emails are winding up in their spam folder, so check your spam folder if you don't see the emails. We have not yet sent out webinar links for the Thursday sessions, so be patient, we'll get those out to you probably tomorrow. The Thursday sessions, all the afternoon sessions, which are concurrent, are open webinars, so we just have to get you the right one. There's no registration process. If you haven't already, please download the data for the hands-on software workshops that you signed up for. If you go to the session descriptions in the program, you'll see those links. And Maggie mentioned already, we have this community forum. There's a link to it in the program down at the bottom, I believe, under participation. And it's a Google Doc. And if you want to share notes or resources, that's the place to do it. All right, so let's talk a little bit more about drone mapping. Why do we have this class on drone mapping? Well, the main reason is because it's just a really cool technology. I mean, the things that you can do with these little devices are just phenomenal. Super high resolution imagery, three-dimensional, multispectral. We're just flabbergasted with how amazing the technology is. And I think once you get involved with the data that we'll be working on, whether you're flying or not, you'll be really excited. But the other reason is that this is really new technology. A number, 3 or 4, engineering, computer science fields have come together in the last 5 to 10 years to make this magic possible. So there's a lot of new things to learn. There's new tools you have to use. There's regulations are catching up. They're also the technology of regulations are catching up. So unless you've been in school recently, there's not many places to get this whole breadth of knowledge. So the goals of DroneCamp are really to give you that menu, that landscape of everything you need to know to use drones for mapping. Because it is a lot, as we're going to see. Most people are learning on their own, and that's a good way to learn, but it's also kind of inefficient. So there is a learning curve to using drones to make maps and to collect data. It's a steep learning curve. Our hope is that this will at least accelerate your progress of that learning curve. We want to give you some hands-on experience with data processing. That's one of the least intuitive tasks in working with drone data. Most people are using drones not for mapping. They're using it for video, for photography. These are easy. There's still a lot of tricks to the trade, but the data processing is is a big part of the using drones to make maps and collect data. We want you to reduce the errors that you make in collecting data, as well as accidents that you might have flying. And as Maggie mentioned, a big part of this initiative, and one of the big reasons we do this, is to build the network, right? Because there's people all over the country, all over the world, who are using drones for really cool purposes. So let's get a little overview of what we're going to be looking at over the next 4 days. So this is a little graphic of kind of the drone mapping workflow, and we're going to look at some of the sessions within DroneCamp where we'll be addressing some of these things. Now, obviously, it's not a linear process. And when I was thinking about what sort of metaphor to use, whether Candyland or Chutes and Ladders, it seemed like Chutes and Ladders might be better because there's a lot of slides when you make a mistake and have to repeat work. But nonetheless, for illustration purposes, let's think about some of the things you need to think about and do. So like any kind of project, you have to think about what are your goals? Is it science? Is it management? Is it just maybe visualization? That's makes sense. But it's often important to maybe detail your goals about what kind of data you might need. And then do you really need a drone, right? So we found that the drones are not a panacea. There's a lot of hype about drones. Where they really add value compared to like satellite images or aerial photos is when you need really fine spatial resolution, so very small pixels, maybe because you're looking at small objects. So you want to look at individual plants or individual leaves. If your area of interest that you're trying to understand is small to medium size, drones can play a good role. They're still relatively close, you know, they don't have a lot of flight time. So if you want to map half the county or a ginormous watershed, drones may not be your data of choice. They have the ability to do high resampling, so you can refly the area frequently, which is really important for certain types of applications. They're not as expensive as, for example, hiring a service to do aerial flights or even to purchase satellite images. The time, people think drones are really quick, and the flight is really quick, but the overall time required to use drones for mapping is not trivial. So I would say it's a high time investment and you need to be ready for that. Also, if your question or your goals require 3D structure or multispectral, then that's another area where drones are probably going to provide you some value. Okay. So one of the ways that you can find out, like, are drones right for me and for my work, is to look at what other people are doing. And we're going to have DroneCamp is primarily instructional, but we will have several sessions throughout where you will actually see how people are using drones for actual research and projects. And one of those will be on Thursday. We have a session on UAS applications in coastal marine systems, which is really cool and has some specific challenges, but please come to that. You hear some talks about how researchers all in the central coast of California are using drones to map kelp, to look at the intertidal zone and so forth. Another thing you have to do when you're planning drones and whether or not you want to use them and how you're going to use them is to think about the equipment. It's not just the drones, it's also the cameras that you put on the drones, the various accessories. So later this morning, we're going to have a session all about equipment, specifically drones, fixed wings, the EB, it's a sort of a smallish fixed wing, and the various cameras that you put on your drones. And that's changing quickly, but we have some really good speakers who are up to speed on that. On Thursday, there'll be another session as part of that coastal and marine applications on the larger fixed wings and VTOL, so vertical takeoff and landing. This is a new generation of equipment, really, really cool, coming of age very quickly, and we have a couple speakers who will talk about the VTOLs, as well as a larger fixed wing from here. Something else you need to be aware of as you're planning your drone work are the safety and regulations. These are multi-layered. You've got the FAA rules, which are pretty well established, but then there's lots of murky waters with state and local and agencies changing a lot. This is stuff you need to be aware of to use drones for work and to be safe about it. We're really fortunate that Brandon Stark, who works with the University of California system, is an expert on all of these aspects, and he's going to lead us through later this morning a session on safeties and regulations. Be aware of that. So that's kind of the preparation work. When you're actually ready to start collecting data, mission planning is another step. And there's tools that make that easy. Later this afternoon, we're gonna have a session on mission planning. That's definitely worth checking out. There's apps that make it easy, but you also have to understand some of the basic underlying principles of how to plan your flight so that you get good images for your mapping project. If you're doing an application that requires high precision, so maybe you have some sample data from the field that you've collected with a GPS unit, for example, or you're going to be repeating a flight multiple times and you need those images to really overlay each other very precisely so you can look at change detection or growth or something like that. There's some extra steps to do that kind of super high precision mapping, and Pat and Pietro from CSU Monterey Bay is going to be going through some of those tools, techniques, and equipment and procedures for high precision mapping tomorrow at 3 p.m. So come back for that. So at this point now, you've done a lot of preparation work, and this is where the fun part is. You actually start to fly. And flying is what attracts a lot of people to the field. Time-wise, it's relatively the small part of the workflow, but there's a lot of tricks and techniques to fly safely and collect good data. So there'll be a couple sessions coming up, being a good visual observer. Brandon Stark is going to have a session about that tomorrow, being part of a flight crew, being safe, looking out for obstacles. Later today, Sean is going to talk about planning and preparing your equipment, planning to go to the field, some of the things you have to do to get ready for that kind of stuff. And then on Thursday, we're going to have 2 more sessions on maybe more advanced topics around flying. One will be working in controlled airspace, which is largely around airports. So Brandon's going to talk about some of the rules to be aware of and some of the tools and procedures you can go through, and then also night flying, which is another kind of special application of flying. Okay. Then we have 4 different workshops that will focus on photogrammetry. So photogrammetry is where you take these images, you pull them off your drone, and now you're going to stitch them together to create these spatially accurate products, the orthomosaics, the 3-dimensional products. And this is broadly under the term photogrammetry, and there's different programs that make this easier to do. So tomorrow morning, Maggie's going to give us kind of an introductory talk to the science and the tools of photogrammetry, so you understand some of the concepts, some of the language. And then we have several workshops on Tuesday and Wednesday where you'll actually get to play with these various programs. And there's been a lot of emails about signing up for those and downloading the data and so forth. So Pix4D is one of the programs. Sean's that's the one that we use in our unit quite a bit. It's a very good professional grade photogrammetry program. ArcGIS Pro also has the ability to stitch images together. It's one of a handful of platforms that Esri provides that can do this kind of stitching. And then Metashape and Open Drone Map. There'll be workshops on Wednesday covering those photogrammetry programs. And we're really, really pleased to have both of these because these are both new programs that we haven't been able to cover in DroneCamp, in previous DroneCamps, but partly because we're going virtual, we're really lucky to have Malika Noko from UC Davis with Logan Ebert, and then Corey Snipes is part of the Open Drone Map community. He'll be joining us from Ohio and leading us through a nice workshop on Open Drone Map. And I think probably the best developed and maybe the primary open source platform for photogrammetry. All right. So another aspect that everyone will encounter sooner or later is how do you manage your data? Because so you have the images off your drone, and those are JPEG files or TIFF files, so they're manageable. But then once you start processing it, it explodes, and you have all these other data. You have GIS layers. The volume of data expands by like an order of magnitude. So it's not trivial, and thinking about how you're going to store these data, how you're going to back them up, how you're going to share the results. That there's a whole nother bag of tricks and techniques there. So we're going to cover that session on Wednesday morning. This is very much an evolving field, and there's different solutions people are using for different types of projects, but we'll share what we've come up with within our unit and suggest some various tools that you can work with. Finally, another part of working with the data is after you stitch these images, usually that's not your final goal. Right? Unless you just want nice, sharp images to put up on your website or to share with your community, you might want to do some more analysis with GIS software. So there's going to be 2 workshops on Wednesday that will help you learn how to use GIS software such as QGIS and ArcGIS Pro to do things like compute vegetation indices, to take that 3-dimensional model and do interesting things with it, to extract pixel values for sample locations, and so on and so forth. So those will be really useful workshops. And again, they're using standard GIS software, but tailored to working with the data from your drones. Then drone mapping and drone science is rapidly changing, and there's a lot of innovation going on. It's a novel kind of data set, so people are asking new questions that you couldn't ask those questions with satellite images, for example. And the data is really novel. You've got multispectral, 3-dimensional point clouds. So we have several talks on Thursday where we'll hear from researchers who are actively developing new ways to work with these data products. So Malika Noko and Logan Ebert will describe how to sense water stress in crops using thermal imagery. That's a type of drone data, and that you can use to look at water stress in plants. Ali Pereza with Ali Mogini and German Zuninga Ramirez are going to talk to us about work they're doing in their lab, also at UC Davis, on digital agriculture and new tools and techniques they've developed to both process imagery as well as to analyze the 3-dimensional structure and so forth. So that's stuff coming right out of the lab, active research. We also have on Thursday morning a series of speed talks from DroneCamp participants, you guys out there, where people are using drones for different types of processing. So that's really, check out those titles, and that should be really good as well. We recognize that we are there are many people, including many people here in DroneCamp, who are super experts in what they do. So finally, the end goal of all this is not just to have like a little course, but really we hope to, in a larger and longer term sense, to stimulate a community of drone users and drone mappers. So some of the sessions on Thursday are also going to talk about different ways that we can all get involved in training the next generation of drone operators. So Wing Chung and Ken Yano are from the UA STEP. That's a program in Southern California, which is developing curriculum for professional development training in community colleges. They're going to talk about some of their work. And then we're really pleased to have Diana Robinson and Alina George from the FAA, who will talk about the FAA has a collegiate instruction program, or collegiate instruction training program, which they've had for a long time, but now there's a drone component too. And again, this is all about helping colleges develop programs and curriculum and standards for training drone operators and drone mappers. And then finally, our sister program, the DART, Monterey Bay DART UAS Symposium, they're gonna have a lunchtime talk on Thursday. Normally, our programs are back-to-back, but this year we all have to go virtual, where they're gonna talk a little bit about their symposium, their plans for their symposium, which I believe is gonna be in October. So check in for that. And that's an overview. That's what we're gonna be covering for the next 3-4 days. So as you can see, there's a lot of dimensions to it. We're aiming for breadth, not depth. Nobody will be an expert out of these 4 days, but hopefully you'll at least have a menu of what you want to focus on as you continue to develop your drone projects. All right. Okay, I'm going to go ahead and now we'll look at some case studies from Sean. And Sean, if you are okay, you can just say next slide and I'll click it, or will that work?
That sounds good to me. Thank you. Well, first off, I'd like to thank everybody for joining us at this new formatted drone camp. This is a very exciting event for us. I'd also like to thank you all for joining our community of drone scientists, professionals, and all-around enthusiasts with this technology. This is a really neat and emerging field. I say emerging, even though it's been around for a number of years, but all of the technologies are coming together, and there's getting to be enough critical mass of people like us that are using this technology to really have it go somewhere. I know I've already been introduced a little bit, but my name is Sean Hogan. I'm an academic coordinator with the Division of Agriculture, Natural Resources, located in Davis, California. I came to this division about 6 years ago, and I came from a background of remote sensing through my graduate work. And so when this technology came around when this technology started to explode in 2016 with the doors opening through the Part 107 regulations and the institutional acceptance of the technology, I was able to jump into the technology pretty much over my head, and it's been a fun, wild ride since then. When we put on these events, the one thing that I always try to focus on is what I wish I knew when I first started working with the technology, and with that in mind, I want to talk about just a couple projects, just as case studies or case samples of what might go into a drone project, just to give you kind of an idea of where we're going and how we're kind of arranging the entire drone camp, which, as far as I can tell, is maybe one of the most comprehensive drone training events in the country at this point, because it covers such a wide breadth of hands-on and theoretical, practical applications of the technology. Starting off, I'd like to point out point to three missions across two different projects. The first one, which is down in the Mojave Wilderness Preserve, is what we're seeing on the slide right now. This mission was to identify washes throughout the Mojave Desert, because these washes are used by endangered desert tortoises as kind of like highways for their movement patterns, which, as it turns out from telemetry data, these patterns are extremely systematic. And if a road or one of these washes gets blocked off, they found telemetry data with tortoises were walking back and forth until they died trying to cross a barrier fence where their highway was essentially shut off. So this study was to create a very, very detailed wash system delineation, and then compare that to the telemetry data, and then be able to use that for regulatory suggestions. Next slide. This included two significant campaigns. The first one in 2016 was the first large project that we ever conducted. It covered 1,200 acres, and this was done with a simple 3D robotics solo drone and a GoPro camera. Again, one of those things I wish I would have known then what I know now. It would have been much easier to do that with one of the DJI products, because of the processing time that was involved with stitching together that much area using GoPro photos. Then Andy and I returned to the same area, essentially across the road, to the Mojave National Wildlife Preserve in 2017, where we covered 2,300 acres with a Matrice 100 drone over the course of 5 days. Next slide. Then last year, I returned to an area just slightly north of there, to the Tecopa Valley, where I flew 700 acres with a EBX drone. So this was conducted with a fixed wing. Again, and I show this because it's, again, almost the same kind of that workflow, as well as data products with the stream delineation, in this case to look for habitat suggestions for the wild vole area in that area. Next slide. So what I did is, and I'm not going to belabor this, but I sat down for a little better than an hour and counted up the amount of time each component of these 3 missions put together entailed. And this is a little graphic of what I found. A lot of people, they think of the drone flying is kind of the centric idea of what it goes into a drone project, but that's actually a fairly small proportion of what goes into a mission. Next slide. I found that the flight time was actually only 7% of all the time spent. And there's a lot of things that go into this that might not be thought of beforehand. And an example would be mission planning and project coordination. There was significantly more time spent on that alone than the actual flights. When I talk about mission planning and project coordination, there's a lot of things that go into that, like your grant proposal development. In the case of the wildlife preserve, we had to put in applications for flight authorizations 3 months ahead of time. That included a safety plan and a safety report, coordination with the researchers and teams. And the way our unit works is kind of interesting. We're both a service unit for the Division of Agriculture and Natural Resources, which is essentially the cooperative extension branch of the UC system. So we coordinate with researchers and outreach folks to put together projects, but we also do research of our own. And when it comes to something like this, where we collaborate and even publish papers from our work, there's quite a bit of original planning and coordination that has to go on. Then we have also the administrative and organizational authorizations, a weather review. I mean, these little teeny things, they all add up. And then it comes to the actual mission planning, which people would think of, like how to set up your missions on your apps before you go out to the field. The gear preparation, that is also a large part of it that can be underappreciated. This could include all kinds of things, one of which is there's so much battery charging that has to go on. Not only your drone batteries, but your tablets and your controllers and your computers. You have to set up, and during that preparation time, you have to set up your firmware or recheck your firmware, because the last thing you want to do is get in the field and find out you can't fly. Then there's all the loading and unloading gear, which I know it sounds kind of trivial, but it isn't. When you have to go get your equipment out of your storage or your office, get it loaded up, drive 10 hours to a project site, and then unload it, and then reload it, and then unload it, and it keeps just over and over. So there's quite a bit of time that goes into that. Then there's the logistics of drive time. There's the GCP placement, so ground control placement is involved in a lot of projects where you have to go out in the field. That almost always, well, I'd say almost always, it's usually on par with the amount of time you spend flying your drone, is putting out ground control targets and recording their positions with a GPS, and that goes into the flight processing later on. And then comes the fun stuff after the flights too. I mean, I say the fun stuff, but I count all of this as fun. It's all a logistical puzzle that you have to work out. Finally, you get to the data management and processing and the mapping and analysis. These go together, where you have to run your imagery through some form of software to create usable mapping layers, and then the mapping analysis kicks in. And this is really project dependent. In this case, it included stitching the imagery together into what there was about 3,500 acres of coverage at around between 2 and 4 inches of spatial resolution. And then with the mapping analysis is using models to be able to figure out where are the stream flows and create usable maps to deliver to our colleagues. And then that delivery, the data delivery and documentation, that has really improved within our unit over time. And we'll have a session on data management and tomorrow or the next day that will touch on some of the lessons learned that we've come up with through our I'd say trial and error, but but learning things the hard way sometimes. Next slide. So for this workshop, of course, we're all well, not all of us, but a lot of us are more or less locked down due to the unfortunate circumstances with COVID. And so I've as a UC policy, non-essential travel has been frowned upon. Well, as it so happens, my family has a 117-acre ranch up in El Dorado County, which happens to be a really ideal spot to collect data really efficiently and easily. So I collected data over a holding pen adjacent to my dad's house to capture a small enough data set that still had a compelling element to it. In this case, there's significant bark beetle kills that are occurring in this area. So just to kind of cover the elements of what went into collecting and conducting this, I mean, minor, not, I would say not minor, but I'd say off the books case study was to fly over this area after laying out ground control targets on the ground, picking out the appropriate launch site, filing flight plans, planning the missions, figuring out what time of day and what days the flights could be done without rain or clouds or wind. And with this, I collected a number of data sets that we'll be using for both our ArcGIS Pro and our Pix4D image stitching workshops. Next slide. So here's a brief video adjacent to the holding pen area that is a little bit glitchy possibly, but unfortunately we can't go out and fly for this drone camp. I know that that's one of the fan favorites, is actually putting your hands on the equipment and flying around. So I just wanted to put in a little teaser of launching the drone, which it seems like the video is stuck. But anyways. There's this was going to be a video of a launch and takeoff, and just is a kind of metaphor for launching our drone camp. And I think that that's probably all I have to say right now. Again, thanks for everybody coming to Drone Camp, and join the community forum and throw in your suggestions if you have any thoughts, concerns, any points of extra interest. And oh, I see the video is playing again. Andy or Maggie, do you have any other last thoughts before we break to the next sessions?
Yeah, so we have about 3 or 4 minutes for questions.